Welcome, everybody, at the last session of International Conference Use of R in Official Statistics. It is my pleasure to introduce you the coordinator of a panel talk, very interesting panel talk about computing in the Statistical Office. So welcome, Alexander from Statistics Austria, to coordinate this virtual roundtable. Good luck to all of the participants, and feel free to ask questions on YouTube channel on the chat. Thank you.
Thank you very much, Anna. Welcome also from my side. I hope you enjoyed the conference so far. This will be the last content of the homepage of the conference. We have 3 discussants today. We are short one discussant who was on the program, Michael White from the World Bank, but he could not join right now. So we have Heather Turner, who you might know from giving the keynote on our first day. We have Mark van der Loo from also organizing committee member from this conference, and we have Matyas Meszaros from Eurostat who joined us today. Welcome to all 3 of you, and thank you for joining us. The topic is maybe a bit general, but we will come to details later on. It's computing in the Statistical Office. And you 3 should have different perspectives on that problem. Heather probably has more of an outside view on what we actually do at the Statistical Office. Mark has a direct view from within the Statistical Office, and Matyas has a broader view, probably as he's at Eurostat, who is governing the ESS, the European Statistical System. So I would start off with a small intro round. So everyone should give a brief history, or should shortly introduce him or herself and give a brief history about like the statistical computing skill set evolved over time, and how they see the development of that. I would start off with Heather, if that's okay, and then Mark, and then Matyas. So please, Heather.
Okay, thanks. Yeah, well, I'm a trained statistician, so my statistical computing started in my undergraduate degree in statistics, where I was it was part of the training to learn SAS programming and other statistical software. And I also did a year in an agricultural research station, and that's when I really started getting interested in programming, statistical programming. And there I was using GenStat, which is used a lot in agriculture. And I started with R in my PhD, just teaching myself what I needed to know to support my research. And then after my PhD, I became a research assistant, and it was there that I sort of started learning perhaps more formal software development skills, because it was part of my role to create an R package. So I started learning about and using version control, a proper IDE, and so on, with the support of my mentor. And then since then, I've worked in academia and in or with industry, particularly the pharmaceutical industry, developing statistical software and workflows, mainly with R. So that's my background.
Thank you very much. We go right over to Mark, please.
Yes, my computing experience also started at university. I had, well, part of what I studied was one obligatory course was numerical methods, where you learned to write algorithms in Fortran, and also made very aware of all kind of things that can go wrong when you assume the wrong things about how computers work. They don't work with real numbers, so to speak. They work with total precision numbers. And I was really, and I'm still very interested in doing both the math and actually the application. So going from one to the other. And so then when I was doing my PhD, that was in molecular physics, we were basically trying to solve Schrödinger's equation using our own software, using MATLAB and Fortran as well, and a little bit of C. But looking back in those days, we did a lot of programming, I think numerically very accurate, but things like software development skills like version control, decent documentation, making code transferable, but something that I absolutely did not learn there. We did not focus on that. We were really focused on the subject matter. And yeah, I haven't read my code back from those days in a long time, but I'm also a little bit afraid of doing that. So after my PhD, I started in the Statistical Office in the Netherlands. And well, I was really used to MATLAB, and when I saw they had S+, so that immediately attracted me. I would do consultancy jobs, I would do some research, and I would write scripts to analyze data and to write small algorithms in S+, and later, quite soon after that, in R as well. And then when R became sort of a structural tool in the Statistics Netherlands around 2009, 2010, I started also investing a lot of time in it. So I started writing a first package to support a method I developed for outlier detection. I think I published it in 2009 or 10. Then also started learning about things like version control, documentation, which is what you are forced to do also when you write an R package, right? You have to document. Later also testing, automated testing. And well, that lasted for about 10 years. So, and here we are now. 8 or 9 R packages, I think, and sitting here.
Thank you, Mark. Matyas? Yes.
Okay, I will start a little bit back because I started programming 30 years ago in Pascal and BASIC. So it was different things. Then at the university, I studied economics. So I had statistics, mostly in paper and with calculator. Then later on, I had a chance to learn some of the softwares as well, like eViews, Stata SPSS, or Gauss and GANS during my Erasmus in Maastricht. Later on, I started to work in mostly IT field. I was working doing simulation in MATLAB. So again, it's a little bit different what I was doing. And in my other field of works, I was started to using R and Python when I started to really work with data analytics in a larger scale. Previously at my PhD, R wasn't mentioned at all. I was using SAS, eViews, and Stata, which was at the time. But now, when I started to work real application, and usually if I go to the private sector and they have limitations in softwares, then they turn to open sources, and then I had to learn Perl, Python, and R. So this is my background to here. And then as well, on the way, I learned on my own doing the stuff and then learning what is the best practice, learning a lot of from reading on the internet. So this is my background.
Thank you, Matyas. So just 5 words about myself, because what my background is. I'm not a blank page in the discussion. My background is not too far off from what Mark's experience was. So I obviously started using R in university. So back in like 2000 and maybe 4 or 5, something like that, maybe 6, I don't know. Vienna was quite the hotspot for R. So I had Fritz Leisch in something, I think it was called Statistical Computing or something like that, and he introduced R to the students. Figured a point in time when it was not very common to do that at a university. And then I started at Statistics Austria right afterwards. After I finished my master at Technical University of Vienna, and there we were kind of forced to use SAS, but we kind of had a grassroots movement to begin and work with R. And I think in 2010 we were then officially allowed. So after like 2 years where we used it, we were officially allowed to actually use it. Within a maybe strange setup that we were allowed to use it within the methods unit. So that's where I worked back then and where I still work, but not outside of the methods unit and not for production purposes. So we were actually not quite sure what we should do then, because I mean, we obviously developed methods, but we also had to apply methods in our statistical production process. So we had to impute data and weight data and do the steps that were our responsibilities. And we did that in R, and we kind of ignored that it should not be in production. This lasted for a couple of years, and then it's now an official software for don't know how long, for at least like probably almost not 10 years, but 6 to 7 years. And now R is the main tool, and we train our staff also in using R and using software tools to be a better R programmer, R user, like version control and so on. So that's a brief background on my side. I have a first question to start off a discussion, and I would direct it at first maybe to Mark, and then maybe Matyas can add something from a Eurostat perspective. And of course, Heva, if you can join in at any time. So the question is, what computing skills are needed in a statistical office? So maybe Mark can say something about the kind of national perspective, and then Matyas, how it's different in Eurostat setting.
Yeah, thanks. So I only for this question I prepared a few pictures to illustrate. So if I would allow me, can you see my screen?
Yeah.
Okay. So yeah, so part of the reason we have this panel is because I recently wrote something down about this, and I have some figures there that I would like to share with you. So the reason I wrote something down about this is because I notice a gap, or I feel there is a gap between the computational skills that we have in the statistical office and the statistical skills, computational skills that we need. And when I say computational skills, I should first say that I really focus on computing with data. So I'm not talking about building a database or building a graphical user interface or something like that, but really transforming data and doing analysis. Because if you look in our office, at least, a huge variety of tools is used, often also office tools, so spreadsheets, office database applications like Access, and not really the reproducible scripting tools that we like to use, such as, for example, R. So one of the things I did is first to ask the question, like, how important are computational skills actually? So that's my first slide. So what I did was I took the GSBPM, and that's basically just a list of things that we do in a statistical office, general statistical business process model. But it's basically a list of things that we do, types of activities. So it has things like identifying needs, integrate data, classify, encode, and so on and so on. And then what I did is for each section in the GSBPM, I tried to label like where is computing important and what type of computing. Are we transforming data, analyzing, or building tools, or reporting like visualization? I also distinguish between are we building tools or are we using them? Because we build our own tools, for example, scripts and R packages. And then there's the question, is it a core activity of what you're doing in that part of the office, or is that just a supporting activity? So I don't want to go too deep because of time through this whole picture, but you can already see at a glance, I think, that there's quite a lot of activities where computing plays a role, right? So that's the sort of the takeaway message of this picture that you immediately see is that it's important, these skills. And so to put a few of the numbers there, if you look at where is it a core activity, then 40% of the activities on the GSBPM are at its core a computational activity, an activity where we are computing with data, whether it is data cleaning, whether it is analyzing, even gathering in some cases when we do web scraping, for example. It's all computational. In 10% of the cases, it's a supporting activity, for example, improving business processes. And then in about 20% of those activities, we are developing tools. So we are not just running software, we are actually writing software. And it's used in 60%. So there's some overlap because in some cases there's both using and developing. That's just because of how the GSBPM has been set up. But in any case, I think the takeaway message is that if you ask the question, are computational skills important for statistical offices? If you didn't believe so already, I hope this convinces you. So that's the first point. So and then the second point is, so what is the question is what computational skills are necessary? And here I borrowed a picture from Deborah Nolan and Duncan Temple-Lang. They wrote an article on computing in the statistics curricula in 2010. It's a really interesting paper that I would advise anybody working in statistics to read. And Deborah Nolan later on became very important in defining sort of the standard curriculum for data scientists in the National Science Foundation Committee, I believe in the US. This was one of their earlier works, and it contained a nice Venn diagram of all kinds of things that you need to know when you are a statistician. And I adapted that Venn diagram, redrew it, and modernized it here and there because, for example, web technology evolves fast. But you can see that there's a huge, wide variety of skills that we need to get from our raw input data to something that we publish on our website and feed to the public. So it's not just computational statistics or things like maintaining databases, but there's also metadata, knowing about data management. There's software engineering, there's reporting and visualization, which has a huge number of subfields like knowing about color, perception, interactive visualizations. Then there's a whole slew of methods that are quite specific and have been developed within official statistics. An important subcategory is, for example, when you do statistical disclosure control, we have very specific methods there. But things like small area estimation is a very important method or family of methods we use. And these are all highly computational things that we do, and we put it that way. My first conclusion is that it would be nice if we would know like how many people do we need in the office that know all this. It's also clear that you cannot have one person knowing everything in sufficient depth. You probably need a team. But I hope to, at least with this graph, to sort of inspire people and realize like how much it is actually and how wide it is. And maybe start a discussion, like for example in this panel, like how do we get enough people to know about these things so we can better automate our systems. So that's my sort of, I'll stop sharing here. Sort of view on the matter. And again, I see a gap where we have IT specialists who know how to build a database and know how to write a graphical user interface, for example, and they know how to maintain things like infrastructure, but they usually don't work with data. So they're not familiar with the problems you run into when you work with data. We have methodologists who know about methods, but unless they are really interested in it themselves, are not required to know numerical methods and implementing methods. It's sort of by coincidence that people do this. And then we have the domain knowledge experts who know everything about economy, demography, and so on, but often lack the skills to write a really good script. So part of the software engineering, for example, that you saw in the slide. So that's the sort of the gap that I see. Yeah, I think I'll stop here.
Okay, thank you, Matt. So, like the IT tasks are divided in, what do you say, between like IT, subject matter and methods unit, and that's already organizational, at least in our office. So we have projects where IT department like codes or develops part of the whole process. Methods produces something, and then the subject matter experts also at the end produce something, produce code to produce the statistics. Matyas, how do you see that in relation to Eurostat?
In Eurostat, the situation is a little bit what we see, that we have a central IT as well, where we are coming the domain experts and they try to explain what they need and they try to do it. And then the issue is when we have no flexibility. What the IT is done, they are doing based on the software engineering rules. But we want to change, we want some flexibility. It is an issue that we have to always ask the central IT to change something. There is no possibilities. As well, I see more and more people like to do something on their own, not just like central IT. So there is this change, internal change as well in Eurostat. And what I see, at least we know what really the needs. Okay, they have to know something about basic programming, to know what is a cycle, what is a loop, what is a different object orientation, and so on. So at least they have the basic concept. And then, but the other thing, they have to learn to read documentation and error messages, because it's quite important to understand when they are doing, they try out new things to understand, because what I see as well, many times they face an issue, they go again back to the central IT, and then they tend to find themselves in the same situation that to solve on their own, so with their skills. So this is how I see the improvements, what it's needed. And maybe it's not a skill, but maybe it's a mentality change. And for the younger generation, it's already there when they see, but for the olders who are already in the business for 20 years or more, for them, it's a bigger change, and for them, it's difficult to accept this. So again, it's not just about the skills, the computational skills which is needed, but as well about the mentality towards what we are aiming for, which is needed as well. And of course, the support from the hierarchy that we are going in that direction as well.
Yes, I recognize the decentralization that's happening in our office as well, actually for quite a while, where there's really a shift from, especially for the important projects, where you specify what you want to IT department, they build it, and then they give you an application. But now that, you know, things in the outside world change faster than they used to, especially as we become more dependent on existing data sources and less on surveys, we need to be more flexible. And then it's just not possible that IT builds every piece of processing software. I mean, we produce about 4,000 high-dimensional tables every year, so that's 4,000 processes. And you cannot automate that all with one department. So the automation has to happen sort of outside of the IT department, unless you want a huge IT department. And that means something for the skill set that you can expect outside of IT department. I think there's still some work to be done. And I agree, it's also, it's not just the skills, it's also the way you approach a problem. See, Alex, you were out for a few seconds.
Oh, okay. I hope I'm back and you can hear me. So I like the idea that that you need a change of mentality, and that we had the problem at the beginning of our journey that we were actually recognized as being developers. Also, if you write just scripts that are processing data. And for example, it was back in 2008 or 9, when I was starting off at the Statistical Office, it was forbidden to use version control outside of the IT department. But everybody was writing SAS scripts. So basically they were coding, but not in the traditional Java development environment they had for applications. And the version control was not promoted, of course, but it was even forbidden. So we had a strange situation. So the IT department or like management needed to recognize that there are a lot of developers nowadays, or a lot of coders at least.
I think that's a very good summary. Yeah.
Hedda, how do you see that from your experience in academia and also in working with different industries? Do you see similarities to what we explained from the Statistical Office world?
Yeah, well, I mean, in terms of academia, it's always been a lot more distributed, of course, that academics are much more independent and a bit freer in what they can do and used to sort of organising it either by themselves or sort of, you know, in their group, being able to manage and sort of, build their group by hiring a research assistant or whatever that can help them to develop software. But I think, you know, it's interesting what you were saying about just then about people developing scripts and so on, also being considered developers. And I think there's sort of a growing recognition that these sort of computing skills that are needed across the board. You know, a lot of research is dependent on software, and you know, most researchers need some of these skills. As Mark said, you can't expect them all to know everything, and that's partly why there's been this move to sort of have more specialist research software engineers that can focus a bit more on the programming aspect. So perhaps there's been more freedom in academia, but then that can mean that it's a bit more informal in terms of, you know, good software practices. In industries that I've sort of had some contact with, particularly pharma, I guess they sort of fall somewhere in between, and it partly can depend, you know, particularly in something like the pharma industry, sort of how close it is to the sort of research drug discovery end, and how close it is to the clinical trials, where things have to be a lot more regulated and pinned down. And it sort of, there's that spectrum almost from the academic side to the sort of more regulated IT focused way of doing things in that context.
Okay, thank you. You already shortly mentioned the research software engineer. That's something that happened quite recently, or at least I noticed it quite recently. So, and I actually saw quite a lot of similarities to the roles that a lot of us in the Statistical Office have nowadays in terms what we do. Not this part. I think a big part of it was that kind of it was hard to be recognized if you're just developing software for research, right? To get credit.
Mm-hmm.
But the skill set is maybe different. So this there is this famous picture of a data scientist with all these skills, which is a bit similar to what Mark showed before. So this industry framed role of a data scientist, I guess all of us nowadays use it. If we're looking for new hires, we call it a data scientist and not a statistician anymore, because you just get more people answering for ads that state a data scientist than a statistician. But is this data scientist that the industry is looking for also like the perfect employee for us? What do you think? Maybe Matyas, do you want to start? Or do you want to say something to that?
I would say that no, it's not the perfect solution for us. But I would say what we are aiming for as well, that we create a critical mass, the people who are able to do something programming as well and know as well the field, what they are doing as well. So they know the data, but they are not afraid to take software to analyze this doing and do the changes as well, and not just, drop and click and so on, but as well do some programming stuff, something which is more than the regular usage of a different given software. So this is what I would see. And as well, we have to educate them from one point of view. As I already mentioned, the version controlling, because as well we can see the different version of the data as well. We have to control as well the code as well, what they do. So we have to be able to reproduce the same results, what was done in 2020, and not maybe something is changing in 2021, and we want to go back to 2020, we have to be able to redo it, so some cases. So that's why we need to teach them as well all those skills which the software engineer has, not just which the data scientist is. Mostly for me, it's about data analytics, who knows different software, can do the programming, but they maybe don't have the knowledge of the given domain. And here I would say, from our domain experts, we have to somehow train in the field of data science and somehow merge the two.
Thank you. Good point. That it's, of course, domain expertise is quite important in a lot of fields we produce statistics in. So one thing that came to mind during Matyas' reply was something, I'm not sure if I should call it a concept or an idea, this DevOps, and nowadays there's also DevOps So the first one is development and operations, and the other one is development, operations, and security. So the idea from, I guess, IT or computer engineers to how they set up the process from the beginning to the end of producing a product, and also like launching the product, so operating the product. I looked at that a bit and saw a lot of similarities of how we should, or also how we actually are already organizing our production process. Mark showed a picture of this GSPPM, and there's also a view of GSPPM with two cycles, so a small cycle for the steps where you basically produce new results, and a bigger cycle where you specify needs and design your tools. So that's a bit similar to development and operations in IT, in the IT world. So this, do you think that's something we should focus more on, so that these concepts that are there in a generic level, like GSPPM, should be also implemented as a actual IT process? So that's actually something you, like Matyas said, you wanted to go back to 2020, you just click on a button and can run the whole production process again?
Who are you asking?
Whoever wants to reply.
I would say definitely. I mean, that's the ideal, right? If you would just, could say, make statistic again, or something like that. that will be the ultimate solution. Yeah. And it goes back to the previous question, the mentality. Do the domain experts who are writing this stuff, do they see themselves as developers? Do their managers see themselves as developers? And that's the first step. And once the answer to that is yes, you can think about how are we going to handle projects then. But I'd also like to come back a little bit to the question on whether a data scientist is the ideal employee or the ideal. So Matyas says no, and I'm inclined to agree. But maybe from a different, to look at it from a different angle. I mean, if I look in what data scientists typically do, they are data science in most businesses is a supporting role. You support business decisions using available data. And for us, processing data is core business, right? So the actual output of our institute is what a data scientist would do. So that's the role would be different. You would not be supporting people making decisions like setting up an advertisement campaign or something like that, a marketing campaign. You're actually producing output that has to be reproducible. There has to be a production process that we can run every month. So it's in that sense, it's much closer to developer than to an analyst. And there's also the difference between the role of a business in society. I would say they are, I mean, a business wants to survive, they need to make enough profit so they still exist. And, you know, in terms of analyzing data, is that, or for a data scientist, it means you only have to be better than the competition. And you also have the freedom of choosing your demographic, for example. You can focus on your target group where you want to sell your products, for example. But we are much more interested in creating a ground scientific truth, saying something about society. So I think the science part of data science here is in that sense more important than in many cases outside of NSIs. And at least that's what I really see in our culture also, for example, in this conference.
Yeah, and I think maybe in that sense it's a little bit closer to academia in the sense that you're sort of contributing to the knowledge, to the public goods, and you know, developing the research methods and sharing those research methods. Obviously, you do get some of that in data scientists do that, but that's not the sort of general job role in industry.
In our field, of course, transparency and reproducibility are quite important. And I guess that's also true, obviously, for academia. At least if you like transmit a paper, it has reproducible results. So there's some similarities probably. Do you know from academia that it is mandatory somewhere to either use or to publish in open source tools? So if you develop a new method, that you actually implement it in an open source tool?
Well, this is one thing I found quite strange, actually, because I've returned to academia after a break of 10 years, and I've you know, come back as a research software engineer, and so I'm sort of getting more involved in the general research software engineering community, and I'm a bit surprised that open source isn't sort of taken as an assumption. You know, sometimes, you know, there are people that still sometimes argue for proprietary software on the basis that it can be more sustainable, or you know, that they get the support benefits from having a commercial company maintain a software. So it's not the same in all domains, I think. Yeah, and disciplines. So there's still quite a mix of people that you know, some are very much committed to open source, and that's the core principle. That's not necessarily the general rule, which you might find surprising. But I think there is, you know, part of the motivation for improving people's software skills has been what you were just saying about being able to reproduce and validate other people's work. There's not quite the same thing, I guess, as in the Statistical Office, because you've also got the motivation of wanting to be able to do much the same analysis the next year, and it can be a lot more one-off in academia. You still want other people to be able to reproduce and validate.
Yeah, that's true, probably. But I hope academia is further on kind of pushing for open source in most aspects. In the session with the keynote by Edwin de Jonge, we had a discussion in the chat about we have something called the code of practice, where our principles are written down. If one of the principles should be that we kind of enforce open source for using and so use open source and also being open, so you publish your code. The only instance I know is that, for example, the US Census Bureau, they have to publish everything they do, they have to publish. So the code they would develop, they have to publish, but we don't have to do that. We kind of sometimes have to fight that we are allowed to publish the code we do develop.
Yeah, I think there's a bit of a difference perhaps between the code that you're writing to reproduce your work and the product itself. You know, so for example, you might use Stata to do an analysis, and you can share the commands that you use to do your analysis, and you can share your data. And then if somebody has a Stata license, then they could reproduce it. So yeah, there's a slight difference there.
That's true.
Concerning as well, just what I heard as well, that in INSEE, in the French Institute as well, compulsory to publish the code what they produce publicly. So that's why there is a policy for in France as well. And just one more remark concerning Mark's statement. Yes, I agree that for new generation, data scientists are better, but we cannot replace all the colleagues. So for me, the data scientist next to a domain expert is not the optimal solution. I would upskill our colleagues, then apply a new person next to them. And this is how I see that. In the future, for sure, we need those skills, but data science is, I would say, gives the background, which we'll need for everybody later on.
Yeah, actually, I agreed with that. I was just pondering a little bit about what pressure there is for academia and for NSIs to adopt open source. I mean, for academia, it's really the ethical thing of you need to publish reproducible results that everybody can access and check. It's the foundation of scientific endeavor, that you publish something, somebody else can check it. And we are also bound by scientific practice. There's something called the European Code of Practice that sets a few principles that every NSI should satisfy, and we will be actually peer reviewed against those principles next year. But we also have a pressure that coming from efficiency. So that's one thing that we try to use to convince our management to use a tool like R, because it's not just as much that there's no licensing fee, because there are other things that come into cost of ownership. Somebody has to install it and maintain it and so on. But it gives a really good opportunity to share packages, for example, methods, tools. And that's, I think, where really the cost effectiveness comes in. And I don't think that's something that's would be very convincing in universities, because it's more of a one-off, like you said, Heather, it's more like you do one-off projects, comparability over time of research. Like for us, comparability over time of a figure is extremely important. If we count the population this year, we have to do it preferably in exactly the same way as last year, and the same with economic growth. And then having sort of standardized tools that are available and that you can share becomes really important. So that was sort of a bit of response also to Alex, who thought that they are maybe further in academia. because of the ethical pressure, but maybe we sort of have the budget pressure is also helping us in that respect.
Yeah, I mean, I think if you're in a if you're a statistician and you're developing a new method and implementing that, then there's a strong argument for doing that in open source, you know, so that people can actually check the method itself. But there is also, of course, the financial issues in academia, and I suppose one argument for sometimes not using open source is that then you can give sort of rely on businesses to sort of contribute in some way by you know, developing the software itself and maintaining it. So it's a way of outsourcing that, I guess. So you have these competing pressures in all fields, I guess.
Yeah, Matyas, how do you see the use of open source? Is it something that's also maybe helping the integration of the European statistical offices so that they are working more together and more similar?
I wouldn't say just the open source, sharing the code like we do as well. For example, sharing SAS code as well, you can do it because many offices use SAS. So if you share the code, you can reproduce. And that's why I see sometimes in academia that, okay, I'm using Stata and others are using Stata, so that's why I'm using Stata as well. And then although I share my code, my work is reproducible, but still I am using a proprietary software. What I see as well concerning the open source, we are aiming for open source, but the issue in many cases is the support. And then when you find to have your own support team, you have to set up. Sometimes it costs more than to pay the license where you have already included there. So yeah, we should aim for it because we have a bigger community. We have more cooperation there. But as well, I see that when we go for open source, we still as well maybe use some paid support for that. So this is what I see at the moment.
Yeah, that's definitely true. Mark, do you want to add something?
Well, I just remembered another really strong force that helped introducing R and later also Python, and that's just demographic changes. Earlier generations of statisticians would ask, where can I start my SPSS? And everybody we hire now asks for R or Python. And so that's also something that it's kind of washes over you as an organization. So either you have to teach everybody to do everything in the old tools that you still have, or you buy or introduce the new tools that they ask for. That's something that when I talk to colleagues from other NSIs, I've heard that as well. That, you know, the young people they hire from university, the first question is, where can I find RStudio? Where can I find my Python Jupyter lab?
That's a good point. But isn't it a little bit contradicting that we must be stable over time and reproducible and should have a good process? Because one thing I'm asking myself is how, in what way it's good to introduce Python into our office. So I shortly tell you how we are allowed to use it right now, and maybe you have different perspectives on that. Because of course we have the demand of new employees who come to us to not use R because that's kind of old-fashioned. But Python seems to be more modern. So how we allowed to use it is, so there's in the GIS world, there's some exceptions, but in general, you're only allowed to use Python from within RStudio. So you can, of course, write Python scripts and so on in RStudio and run the code. And for production purposes, you actually should pack the Python part in a R part so that the production runs in R basically, but it can use Python functionality within, and that's still okay. I'm not sure how extensive this is used or misused by colleagues. So if they just like have one line to call reticulate and then Python and then the closer again. But that's our way we do it right now, and you have to deal with it somehow. Heather, is that something when you work on projects with colleagues, do you also see the pressure that younger colleagues tend to not using R but to use Python?
Well, R is still pretty strong in statistics, but Python is more popular, more generally for research computing. So often that will be one of the first languages that people will be introduced to. It depends a lot who you're working with, but in statistics, like work least, so yeah, I think preference to use R, but I think people are quite agnostic in a way. If it's Python or Julia, or it's sort of what works best for the task at hand, really.
But I would add that still in the offices, what we are doing now, we are looking more at these interpreted languages like R and Python, and not as efficiency like going to C or Rust. So what I see still, we are at a higher level, which is more closer to the not to academia, but to the average user, easier to use for them.
That's quite true. Yeah. So, Mark, can you tell us how it's set up in your office?
You mean the physically the installation, or you mean the difference between the scripted and the?
No, R is kind of also well maintained, and you have a defined environment for that. Have you the same thing for Python as well?
Oh yeah. They're both like sort of strategic tools, I think it's called, so that we are allowed to use them for production purposes. That's the main thing that has to be decided. So we have sort of a central board that decides on what tools to use, and they have all sorts of quality demands. And so Python has been approved a couple of years after R was approved. I'm not sure exactly when, 2014 maybe, so around there. So that means that we have at least some support from the infrastructure guys to make sure that everything is running, that we get updates, and and everybody who requests can get permission in principle to run Python.
Okay, thank you. We have a question on YouTube actually. What about Julia? If it's also a language that official statistics should bet on. My personal opinion is no, because we don't have the capacities for it right now. But what do others think?
I think it's a super interesting language. I mean, even Douglas Bates went from R to Julia some years ago already. But I think it's by far not as complete yet. I mean, there's a huge hump to get over to move to Julia, I think. So there should be really some incentives to move over there. If there's something that you can implement practically only in Julia and would never run from Python or R. As a language nerd, I really like the way it's designed, and I've seen several talks of Jan Witek about it, also at the USR conference. And there's some excellent ideas in there where they learned from MATLAB and Python and R, But yeah, that would be a huge hump, I think, organizationally to move from one to the other.
From the ESS side, I would say we are missing the bigger communities. So still the biggest community is for R and Python, which we see most of the development is doing, not much in Julia.
Okay, I see we also have Michael with us now. Hello, Michael. Sorry about the confusion with the time zones, I guess. But it's good to have you here. And you are the one who can maybe give us a perspective of an international organization on the discussion we had so far on the statistical computing skills that are needed in a statistical office. Can you tell us about the computing is set up and what skills are needed at an international organization, so probably at the World Bank where you are working?
I mean, there are two. Sorry, before I get into the answer, first of all, thank you for having me here. Sorry for the delay and the confusion on the time zone. I see you have already started. Yes, I mean, to get directly back to the question and what I have heard now by listening in at towards the end on Mark's comments also. So we also are a multilinguistic environment, but we have actually two realities. So one reality is the reality we have inside the bank and what do we need for the analytics and all the work the bank does. The other side is certainly what, and that's in particular also my domain of work is the client and what computing skill does the client need? Because as you know, the World Bank also does a lot of capacity building in official statistics and in particular in countries with difficult data environments. And however, certainly these countries also require the same statistical skills as we require in any high-income countries, since they want to make use of the same data, because satellite data is everywhere the same. It has everywhere the same complexity. And so first of all, the environment in the bank is currently a bit, I mean, it was an initial state environment, but it's now expanding more also towards R, Python, so the classic machine learning domains also, but also myself more are in statistics also inside the bank, because it also just has a few features which makes it more interesting in terms of statistical capacities, in particular when you work in the area of survey sampling, survey estimation, and so on. And then certainly for me much more relevant part is the capacity building part we have with open source tools. And this is where we currently, or in particular, my passion is towards using R and Shiny in combination and provide Shiny applications which solve the short-term need of a certain methodology. So for example, let's talk about sampling strata optimization in stratification, for example, and you want to apply that without our knowledge. We have packed it into a Shiny application and use it in that way in capacity building. In addition to that, all the source codes are open source. So in that way, we also then hope that users in those agencies eventually, get, how you say, curious how the app works, and then also look into the code themselves. So that's kind of the two realities we have, and the reality of capacity building is a particular promising one with all the open source tools we have. And as a passionate R user, I say certainly with R and Shiny. So that's my domain, and that we have had quite a few success stories here already. Thank you.
Thank you. and interesting to know that kind of two worlds you are working in World Bank internally and in a lot of different offices. Maybe a follow-up question for that, which would interest me personally. If you build up a shiny application for a specific purpose, let's stick to the certification example, would it produce code at the end? So you click around, let's say, and then you kind of create a script so that the user at the end have a script, or would it be like a traditional graphic user interface that's completing your tasks? I cannot hear you.
Thank you. It's the second one. It's a complete user interface which allows the user to conduct a task without having to go through the whole process of learning how to code it. So that's the main idea. And in addition, since we are also in our department producing data collection CATI software, it's also connected through this environment. So through the API packages, we connect it. And in that way, statistical agencies, in particular in sub-Saharan Africa, with unfortunately still low computational infrastructure and also lack of skills, can use that right away. So they don't need to wait until they have sufficient number of competent staff in the office. So that's kind of the vision.
Okay, thank you. It's actually 4:01 Vienna time, and we should stop at 4. So maybe we make one last round if you want, and not directly related to the topic, or a little bit related to the topic, but on the development of the conference. So now that the conference is almost over, and it's covering kind of the whole computing and statistics, do we need to adapt the setup of the conference, or do you have ideas for adapting the setup of the conference in some way to better target the promotion of R or open source in the Statistical Office? Somebody wants to add on that question? Maybe Heather, you can have a perspective on this conference in relation to useR, which is obviously a much bigger conference, but since you're involved in the organizing committee there.
Well, obviously, one advantage of being online this year, and I think you were online last year as well, is you know that a lot more people can access the conference, and I guess that's particularly interesting in official statistics, as we were just hearing from Michael, where the capacity needs building up in all countries, but perhaps in some countries in particular where they don't have access to such local expertise. So hybrid conferences are difficult, but possibly being able to perhaps consider doing alternating between online and in person or something like that could be considered for future years.
Thank you. Mark, maybe you have kind of internal view of the conference, obviously, but how do you see the development?
That's a good question. I would like to keep the online aspect for sure, and I really hope that we can go to a hybrid situation next year where we can have people live, but also other people who cannot make it to the conference can actually follow it and actually also hopefully participate. So And this, I think, is the most difficult part. To make it a true hybrid conference is one where also people who are not physically there can participate. And that requires probably a lot of work and infrastructure that maybe is not available in all locations where we would like to keep it. But it is something to, I think we should work on, even if we don't get there in the first step. Maybe just to add, because Alex seems to have stopped, because we've always had a lot of interest from a lot of people from all NSIs from all over the world, not just from Namibia, centralized in Europe, being a Romanian conference by origin. But we've always had a lot of interest, people from South America, Africa, Asia. Well, not all institutes have the budget or the means to send people over. Which means that they miss out, but it also means that we are missing out.
Thank you. I hope I'm back online. Right. Yes. Can you share something on your perspective in the conference, please, as well?
Yes. Although I have some issues hearing you, but what I based on the conference is for sure it is better if we can partially keep the online activities as a knowledge sharing, because sharing the slide, sometimes it doesn't give back all the details which is shared during the presentations, so it gives some extra information, and as well gives the possibility to participate some of the colleagues who have some other important task which doesn't allow for them to participate directly in the discussions. So for sure it would be useful to keep the part on the online part. And I agree with Mark that for the personal presence gives bigger interactivity, and if possible, yes, we have to aim for as well that.
Thank you. International participation times to help also contributions and participation from developing countries. How could we better include non-European countries, developing countries, to participate in our conference? Yeah, Michael, please.
Oh, sorry, I didn't because I wasn't sure if Rosetta starts me. Yes, I mean that would be so. This would be something where I could imagine that from the bank side, given that we invested also in the last years strongly into R and also using R in capacity building, and it's more than just an exotic experiment anymore as it was 5 years ago when I came to the bank. So it really is a solid ground. So I could imagine that, I mean, I would need to check the back, but that there is interest also from our side to work together and to co-organize that. Because, I mean, the bank is a strong capacity building unit in official statistics. And then go through our network and make sure that the country offices, if they want, can participate with. Because, for example, the World Bank has country offices in more than 150 countries across the world, all usually equipped with solid communication equipments. So you could, for example, invite certain counterpart client staff into the World Bank office and then let them participate in this way, because in the statistical agencies very often the communication equipment and the internet infrastructure may not be strong enough. But I could imagine, this would be a way, like it's a hybrid, non-hybrid way where you have, for example, the country office, then the conference room there used as the video conference room for such a conference. I could imagine that this is useful, and I mean, if there is interest, then I would definitely be happy to engage in that and to see if I can get that going in the bank. Thank you.
I think the idea of having local hubs like that with local meetups and as well as centralized talks, it would be excellent. So I think we would very happily explore that idea further with you.
Sure, happy to, very happy, because we are really trying hard to establish R also in these statistical agencies, because I mean, I think after the 3 days of the conference, with everybody here, I don't need to talk about the strengths we have with R in the statistical agency, and how particularly useful this is also to close this information gap developing countries have, because it is a huge one. The data is, the data is of the best quality we can get now, but it doesn't mean that it meets the standards we have established in high-income countries, and which unfortunately require to be met to make a statistics meaningful. So in that way, such an additional project with the conference would definitely be something I think it's possible to raise interest, and I'm happy to join forces here. Thank you.
So that would definitely be great. Thank you very much for that offer. We'll come back to you. Thank you to all four of you, Mark, Matyas, Heather, and Michael, for joining us this afternoon for the discussion. I will hand now over to Anna for the official closing of the conference. Have a nice afternoon, a nice weekend. Goodbye.
Thank you. I am very happy that Euros is a public forum to enhance ideas and knowledge, and your panel talk was very, very interesting. Now it is time for some closing remarks and to share some final thoughts on this wonderful edition of Euros. I will share some slides with you. I prepared some figures on Euros at a glance. What meant this edition? This edition of Euros meant 3 days with 2 keynote speeches, very interesting, 2 tutorials, more than 40 talks organized in 8 scientific sessions, the session dedicated to IMO's program, and the panel talk on computing in the Statistical Office, which just ended. In order to follow up after this edition, I would kindly ask you to complete a feedback form, which will be sent by me in the next days, because we count on your opinion to improve your experience with our event. And we thank you so much in advance for this. Also, next step will be publishing the presentations on the website until middle of December. And you are welcome anytime to watch the recorded videos on YouTube, on the YouTube page of Ecological University of Bucharest. And I take this opportunity to thank very much to the team of Ecological University of Bucharest for streaming and recording this event. Thank you. The contributions presented in this edition can be published in 2 journals. The Romanian Statistical Review, which is the Journal of National Statistics of Romania, as every year, and the submissions shall be made to my address, the well-known, and to our journal, the very well-known journal in the community. You can submit directly there at the editorial board, and to please use the keyword Euros2021. The deadline for both kinds of submissions will be middle of January next year. In the future editions, we must hope the ideal scenario next year to be a hybrid event, meaning on-site, but also streamed and recorded for the ones who cannot attend. and will be a very special edition because we will celebrate a decade of Euros events. And I am warmly invite you already to be with us and celebrate. In 2 years, in 2023, we'll be back home to Romania. We aim in keeping this tradition in traveling 1 year in another country, and the very next year back to Romania in the hosting institution, National Institute of Statistics. Until next time we will meet online or on site, I want to just remind you that R stands for R, which brought us together here online now, and for Rainbow, because I'm very much hoping that we will come back to normal times to meet and to socialize as before. I have some other thoughts to share with you without slides. So I want to thank very much to all the participants and speakers because you made this conference happen. I want to warmly thank to Nicoleta Caragia, the head of Euros conferences. I want to thank to the organizing committee, to the scientific board, to the organizing institutions, Romanian National Institute of Statistics, Statistics Austria, Statistics Netherlands, University of Bucharest, and Ecological University of Bucharest. And again, many thanks to the team there for streaming and recording. Special thanks to you all. And I warmly wish you a wonderful time with joy and health for the upcoming winter holidays. I send you warm greetings from Bucharest, Romania. And I want to invite my colleagues from the organizing committee to share some thoughts with you. So see you next year to celebrate a decade of Euros events. Thank you so much.
Thank you, Anna. All I have to add is actually to thank you personally because you had a lot of work with organizing this conference, and to the general public, of course, that if you are interested in hosting a future Euros conference, you can always contact us, and we are always looking for hosting for organizations that would host a meeting. So thank you again, Anna. Of course, thank you also to all the organizing committee members, presenters, and scientific committee members. Yeah. With that, I'll hand over to Mark.
Yes, well, you took the words right out of my mouth. Anna, you did a really fantastic job heading the conference this year. I mean, everything I think went flawlessly. Also, the people who worked the studio and the YouTube streams, it was fantastic. I was also really very happily impressed with the quality of the talks and the contributions of all the speakers, keynote speakers, as well as the regular and lightning talks. And the only thing that I'm sad about is that I did not meet the people in person. I really like to do that and to have all the social events around. So hopefully we can do that again sometime soon. But for now, congratulations for a fantastic job, and we'll see each other again soon.
Again, hello everybody. I miss you all. I want to meet you face to face in the near future. In online environment, we are seeing each other maybe weekly, so it's nice to have you as a friend. First of all, I want to appreciate from my side the high quality of the presentation and the importance of the works, of the results, both for the official statistics and for the academic environment, let's say. In fact, in Romania, we have a long tradition in joining our efforts, meaning that academic environment, academic, let's say, university and the Romanian academy, and more and more extensive collaboration between these entities and National Institute of Statistics. We are grateful for this collaboration, and I am very positive for the future collaboration. So in the end, on behalf of the Ecological University of Bucharest, I would like to thanks to all the participants and assure you that our university will stay very close and it will participate in organizing committee for the next events of the Euros conference. Thank you and congratulations for all the participants, for all the organizing committee, Anna, Alex and Mark, and many thanks to Nicoleta Caragia for having this nice group of people together and to enhance the research and using R in official statistics all over the world. Thank you.
Bye, everybody.
Goodbye.
Stay
Goodbye.
healthy and see you next year.
Yes.
Bye.
Bye.